Yes. In today's class, we will discuss Open System Interconnection Reference Model. I am Dr. Ravichandra Janapati, Professor, School of Computer Science and Artificial Intelligence, SR University, Warangal. Course is Computer Networks. Today session, we are going to discuss about OSI Reference Model. OSI Reference Model. What is an OSI? It is an ISO International Standard Organization that covers all aspects of network communications is the Open System Interconnection Reference Model. So why it is calling as a Open System Interconnection Model? Why it is calling as OSI or Open System Interconnection? Because a system with different architectures can able to communicate with each other. Hence, we are calling it as Open System Interconnection Reference Model. The system with the two different architectures are able to connect, are able to communicate with each other. Hence, we are calling it as Open System Interconnection Reference Model. An open system model that allows any two different systems to communicate regardless of their underlying architecture. Now, this OSI reference model is not a protocol. It is a model or architecture for understanding and designing a network architecture that is flexible, robust, as well as interoperable. So means here we have different types of networks are there. So if different models, so if they are able to communicate with each other, that is called as Open System Interconnection Reference Model. Now, this OSI, it is a reference model. It is exists only in theoretical as well as research purpose. This OSI reference model may not work for another real-time purpose. Real-time purpose, we use TCP IP reference model. For research purpose, we use this OSI reference model, which is a standard model. Now, coming to this OSI model, this OSI model is built upon 7 ordered layers. This OSI model is built upon 7 ordered layers. 1 physical layer. That layer 1 is physical layer. Layer 2, data link layer. Layer 3, network layer. Layer 4, transport layer. Layer 5, session layer. Layer 6, presentation layer. Layer 7, application layer. These are the 7 layers which exist in OSI reference model. That are physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. These are the 7 layers which are very, very important. Now we will discuss the functionality of each and every layer one by one. Now, in a communication, for example, here, this is device A, this is device B. Now, device A want to communicate with the device B, but there is no direct connection. In between, there are some nodes are there. These nodes are called as intermediate nodes. These nodes are called as intermediate nodes. So once we send the information, first it will reach intermediate node, then it will process, then after that it will send it to the next node, then from that it will send it to the final destination node. In between, we have different intermediate nodes. Now, here the left side, the station A, which is assumed as sender. The right side, we have station B, which is assumed as receiver. Now, in between, there are intermediate nodes are there because it is a network. Now, here, the left side, the station A, which consists of 7 layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. In the similar way, right side also, we have 7 layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. These are the 7 layers present in left side as well as right side. Now, here we observing one dotted lines. These dotted lines means there is a peer-to-peer communication. That means application layer in the sender will directly communicate with the application layer in the receiver. There is only that communication. So application layer in the sender side will communicate with the application layer in the receiver. Similarly, the presentation layer from the sender side will communicate with the presentation layer in the receiver side. Session layer. So in the similar way, transport layer, the sender side will communicate with the transport layer in the receiver. So this communication between these two nodes or layers are known as peer-to-peer protocol. This communication is known as peer-to-peer communication. That means the transport layer in the sender side is communicating with the transport layer in the receiver side. The session layer communication, the session layer also similar way. The session layer from the transport sender side will communicate with the session layer in the receiver side. So because of this, it is known as peer-to-peer communication. This is to be known as peer-to-peer communication. Now, so here, this is meaning of peer-to-peer process. The layer 3, for example, between machines, layer X on one machine communicate with the layer X on another machine by using the protocol. This is to be known as peer-to-peer process. Now, within a single side, that means sender or receiver side, within a single machine, each layer calls upon services of the layer just below it. Each layer calls upon services of the layer just below it. For example, layer 3 uses services provided by the layer 2 and provides services for next layer 4. This is the layer 2 provides services to layer 3. That is the now communication between machines is therefore peer-to-peer process using protocols appropriate to a given layer. Now, in between layers, there is an interface. There is an interface between each pair of adjacent layers. This interface defines what information and services a layer must provide for the layer above it. So this is called as interface services. The layer N provides services to the layer N-1. Now coming to functions of layers. Functions of layer. First, we will discuss the very underground layer, that is physical layer. Physical layer. Physical layer is responsible for transmitting individual bits from one node to the next node. Physical layer responsibility is to transmit bits from one node to the next node. That is the main purpose here, which converts your bits into electrical signals. Here, by using some line encoding techniques, we are going to convert your signals into electrical signals. So this is called as, this is the basic function of physical layer. Physical layer is responsible for transmitting individual bits from one node to the next node. Now, another functions. Physical layer is concerned with following. 1. Physical layer characteristics of interfaces and media. Representation of the bits. The physical layer data consists of stream of bits 0, 1. The transmitted bits must be encoded into electrical or optical signal. The physical layer defines the type of encoding. The physical layer defines the type of encoding. Next, coming to data rate. The physical layer defines the transmission rate, the number of bits sent each second. So it defines the representation of bits, data rate. Another one is line configuration, where the physical layer is concerned with connection of devices. There are different types of line connections or type of method, the way we connected. The physical base is based on physical topology, ring star, transmission mode, simplex, of duplex, full duplex. So these are the functions of physical layer. Next, another layer is data link layer. Data link layer. It is responsible for node-to-node delivery of data. It is responsible for node-to-node delivery of data. Now, functions of the data link layer. 1. Framing. The data layer divides a stream of bits received from the network layer into small data units called frames. The data link layer divides the stream of bits received from the network layer into data units called frames. Physical addressing. If frames are to be distributed to different systems on the network, the data link layer adds a header to the frame to define the physical address of the sender and receiver of the frame. If the physical frame is intended for a system outside the sender's network, the receiver address is the address of the device. Next responsibility of the data link layer is flow control. Flow control. If the rate at which the data absorbed by the receiver, if the receiver is slow and the sender is fast, then what will happen? Overflow. And if the receiver is slow, if the receiver is fast but the sender is sending slowly, then the sender is slow. Next, error control. The data link layer adds reliability to the physical layer by adding mechanisms to detect and retransmit damaged or lost frames. Next one is access control. When two or more devices are connected to the same link, data link layer protocols are necessary to determine which device has control over the link at any time. Next layer is network layer. Next layer is network layer. The network layer is responsible for source to destination delivery of the data. The network layer is responsible for source to destination delivery of packet possible across multiple networks. It converts frames into packets. It converts frames into packets. If two systems are connected to the same link, there is usually no need for a network layer. However, if the two systems are attached to a different networks, there is often a need for the network layer to accomplish source to destination delivery. Now coming to the functions of network layer. One important function is logical addressing. Physical address may change and addressing problem locally. If packet pass the network boundary, we need another addressing called logical addressing. If it is in the same network, then we can call it as physical addressing. If it is in another network, means that is network layer. If packet pass the boundary, we need another addressing called logical addressing or IP addressing. Routing the packet to final destination. The network layer is responsible for delivery of packets from the original source to the final destination. Now 4. Transport layer. This layer is responsible for process to process or end to end delivery of the entire message. The transport layer is responsible for process to process or end to end data delivery of the entire message. The network layer provides host to destination delivery of individual packets. It does not recognize any relationship between those packets. The transport layer ensures that all message arrives intact and in order, overseeing both error control and flow control at the process to process level. Next, another one. Transport layer. Transport layer is responsible for delivery of a message from process to process delivery. Transport layer is responsible for delivery of packet message from one process to another process. There are different processes running. Transport layer. Computer often runs several processes at the same time. Process to process delivery means delivery from specific process on one computer to a specific process on another computer. The transport layer header include a type of address called port address. The transport layer header include a type of all students called port address. The network layer gets each packet to the correct computer. The transport layer gets the entire message to correct process on that computer. Functions of a transport layer: flow control, error control, cognition control. Flow control. The transport layer performs flow control end to end. The data link layer performs flow control across single link. Next, another one is session layer. Session layer is responsible for dialogue control and synchronization. Functions of session layer: decision control, synchronization. Presentation layer. It is connected with syntax and semantic of the information exchange between two devices. Next, presentation layer. It is concerned with syntax and semantics of the information exchange between two devices. Functions of presentation layer. There are different functions available in presentation layer. One, translation. interoperability between different encoding formats, encryption, covering plan to clipper text, comparison, reducing number of its data when transmitting. Now, application layer. The application layer is responsible for providing services to the user. This is the final layer where we can dump the code. So application layer is responsible for providing services to the user. This is called application layer. The functions of application layer. It provides user access to network, X500, where directory service, X400, message handling service. So FTM stands for File Transfer Access and Network. So this is regarding OSI reference model. In this OSI reference model, we have discussed what is OSI reference model, what are the advantages, and that OSI reference model networks also. Now, coming to TCP IP reference model. TCP IP protocol, Transmission Control Protocol. It is, TCP stands for Transmission Control Protocol. It is an internetworking protocol used in the internet and developed prior to the OSI. These are the 4 layers. This data link layer and physical layer in the previous one is merged. Then network layer, transport layer, then all other layers, session, presentation, application, that comes under 4th. So here we have 4. 1 physical layer, network layer, transport layer, okay. In today's class, we have discussed TCP IP as well as this one. Thank you, everyone.